The objectives of this study are the following: to know the properties of electromagnetic waves, to explain the conditions of total internal reflection, and to explain the phenomenon of dispersion of light. The procedure for the activity of total internal reflection is to prepare the materials: water, dishwashing soap, glass, and laser. Then mix the water and dishwashing soap thoroughly, and finally, point the laser to the mixture to observe what will happen. A ray of light passes from a medium of water to that of air. Light ray will be refracted at the junction separating the two media. Since it passes from a medium of a higher refractive index to that having a lower refractive index, the refracted light ray bends away from the normal. As at a specific angle of incidence, the incident ray of light is refracted in such a way that it passes along the surface of water. This particular angle of incidence is called the critical angle. When the angle of incidence is greater than the critical angle, the incident ray is reflected back to the medium. We call this phenomenon total internal reflection. Total internal reflection is a phenomenon that occurs at the boundary between two media, such that if the incident angle in the first medium is greater than the critical angle, then all the light is reflected back to the medium. Total internal reflection is the phenomenon that involves the reflection of all the incident light of the boundary. TIR only takes place when both of the following conditions are met: the light is in the more dense medium and approaching the less dense medium. The angle of incidence is greater than the so-called critical angle. The procedure of the activity for dispersion of light is to prepare the materials: water, container, mirror, and flashlight. Pour the water and place the mirror into the container. Point the flashlight into the mirror and observe what will happen. When a white light, the flashlight, passes through a prism or the mirror, it breaks up into an array of several different colors called a spectrum. This breaking up and spreading out of the beam of light is called dispersion or dispersion of light. Dispersion of light is the splitting of white light into its constituent colors due to the refractive index of the surface and the wavelength of the light. It occurs when the white light is separated into its different constituent colors because of refraction and Snell's law. White light only appears white because it is composed of every color on the visible spectrum. Although they are very close, the index of refraction for each color is unique in non-vacuous materials. These unique indices cause each wavelength to follow a different path. Electromagnetic waves are formed when an electric field couples with a magnetic field. Magnetic and electric fields of an electromagnetic wave are perpendicular to each other and to the direction of the wave. James Clerk Maxwell and Heinrich Hertz are the two scientists who studied how electromagnetic waves are formed and how fast they travel. As shown from the figure, the electromagnetic spectrum extends from the longest wavelengths of the radio waves up to the high frequencies of gamma rays. This arrangement strengthens the inverse relationship between frequency and wavelength and energy, and direct relationship between frequency and energy. Electromagnetic waves are members of a family of waves with common properties called the electromagnetic spectrum. All electromagnetic waves or transverse waves can travel through a vacuum, travel at exactly the same speed in a vacuum, the speed of light, 3 million meters per second. Like all waves, electromagnetic waves transfer energy from one place to another, can be reflected, and can be refracted. However, the difference is, each type of wave in the electromagnetic spectrum has different wavelength and frequency. Finally, it can be concluded that electromagnetic waves or transverse waves can travel through a vacuum, can transfer energy, and can be reflected and refracted. Total internal reflection is the phenomenon that involves the reflection of all incident light off the boundary. TIR only takes place when both of the following two conditions are met. The light is in the more dense medium and approaching the less dense medium. The angle of incidence is greater than the so-called critical angle. Dispersion of light is the splitting of white light into its constituent colors due to the refractive index of the surface and the wavelength of the light. It occurs when white light is separated into its different constituent colors because of refraction and Snell's law.